happening, I think. That's not very works, I guess. Well, it's top of the hour. Man, you're right. I think a lot of the newcomers are the newcomers thing, because I recognize most of these faces. Okay. Well, we're going to get started. We're at the top of the hour here. As I was commenting a few moments ago, I recognize a lot of the faces in here, so I don't see an awful lot of newcomers. Who here is like new to the IETF?
I thought.
Yep. Okay.
How about new to art?
Oh, that's good.
Okay. So
a couple new guys, and this is being recorded for posterity.
Right.
So.
And who's here to heckle?
That's what I figured was going on. Okay. Well, welcome to ART. This is, of course, covered by the note well. We don't really anticipate having any technical conversations in here, but if you do go to the microphone and start talking about anything that has IPR implications, you need to be aware of the provisions in BFCP 79 and its related things. You should have seen this when you registered.
And really, if it's to be discussed, you should be talking about it in the working group later.
It's true. All right. So what is art?
Yes.
Yeah.
What is art? Well, classically, it's the expression of creative ideas or creative expression through painting, music, sculpture. It also happens to be the time zone we're all in right now. The Argentine time zone is listed as art. And at the IETF, it's also sometimes referred to as an area review team. But the real reason we're here is because there's another definition, and that's the applications in real time.
So what is applications in real time? Well, we basically cover sort of the top half of what's been traditionally the OSI stack. We hit applications and things all the way down to even handling some of the transport for things like media, like video and audio, that kind of thing. It's kind of a new area that resulted from the merging of an old RAI, which was Real-Time's Application Infrastructure Group, and an apps or applications area group. And it covers protocols, formats, and that sort of thing for applications, both real-time and non-real-time now.
Right. So like we said, for apps, we cover infrastructure, long-established application infrastructure. So this is HTTP, FTP, SMTP, IMAP, POP3, I mean, all the things you would be doing today to communicate, whether it's email, it's web pages. It's also the application, oh gosh, I read this stuff. So application infrastructure stuff, so like DNS, labels, the EPP that we'll talk about later. And it's also been more traditional building blocks, things like LDAP, OAuth, although OAuth is now actually in the security group, it did start in apps. Things like JSON, media types, things like that.
And historically, RAI covered things like voice and video over IP, signaling and the transport, as well as things like instant messaging using Simple, XMPP, those sorts of protocols. And then the protocols that are used to support those kinds of time-sensitive technologies like GeoPro, which could tell you where you are on the planet, which is important for emergency services, as well as ECRIT, which defined the protocols used to communicate with those emergency services. Now, a quick note on the meaning of real-time here. In computer science, more traditionally, you'll hear real-time referring to things that have like millisecond or sub-millisecond timing and guaranteed execution time. That's not what this is. This is real-time communications, which means we're talking about exchanging media with enough latency that you can have informal conversations over it without having, say over at the end of a transmission. And generally this means that you have round trip times for media on the order of 100 milliseconds or less. Before we move on to the other sections of this, we're actually going to be diving into the specific work. I do want to point out that if you have any question, comment, etc., please come to the microphone at that time. We'll have a section at the end for questions and answers as well, but it works well in the moment also, and we're happy to be interrupted.
Gory fair. Does that work? Right. It's got a number on the top. I'll shout.
Okay.
What is the area review team for ART called?
You know, we don't have one, but I would love to have an art.
Right.
Mostly
Yes.
just for having the name.
Well, art critics.
This is
Yes.
true.
Art critics, wonderful.
But so the former applications group did have an application apps directorate, and some of that work is still ongoing, but there's not something for the entire new art area.
I mean, the parallel that we'd have an art directorate, I guess, with an art director. Yeah.
Yeah. So now we're going to dive into some of the details here. We're going to start with the administrative things we've got in art. One of the first things you'll probably hear about is dispatch. What is dispatch? Well, much like we have protocols for routing data, we have protocols for routing work. In this case, that's what the dispatch working group does. If you have work to do that you're interested in, you can bring it to dispatch to figure out where this ought to be done. Whether that's here in an existing working group, whether it's to spin up one of our smaller, lighter, faster working groups, whether there's a need for a BOF to figure out whether this really does need to progress, or if the ADs think it's enough for them to just sponsor it, or if it just belongs somewhere else. But like we said, there's nothing. This group doesn't do anything itself other than figure out where work needs to do, with the exception of certain IANA actions. So if something needs to be added to IANA that wouldn't necessarily require IETF review and specification required, this could happen here.
And one of the important notes to be made about dispatch is it's not something that's required. People can still come in and do BOFs, sponsored by area directors. You can, if you know the work belongs to a specific working group, you can take it directly there. This is to help people onboard work. It's not something that's required for incoming work.
So another kind of administrative working group we have in ART today is APSOG. And this was the area working group. This was the working group where if you have something that requires more than simple AD sponsorship, the AD doesn't feel comfortable running it themselves, but it didn't look like there was a working group that would fit, and it didn't feel like spinning up a new one, this is where it went. So there's a number of just very small things that are currently in APSOG. However, as the slide mentions, we're looking at that working group is looking at being closed. Like with the emphasis on trying to do smaller, working groups that spin up, get their work done, and shut down, having one general area working group running all the time doesn't seem to fit that model anymore. So it's got some things it's finishing up, and then hopefully be closing before too long.
Okay, so now we're going to talk a little bit about some of the media transport and signaling aspects of the work that happens in ART. I'm going to talk through a little bit. So one of the big building blocks for actually getting media from one side of the network to the other is the real-time transport, or RTP. And it carries time-dependent signals, audio, video, real-time text, that kind of thing, through packet networks like the internet, with timing information associated with it. And generally, you have these streams of media that we've broken up into individual chunks, put in packets, sent across the network using something like UDP, a potentially lossy, potentially out of order protocol, and then they're received at the far end with something that waits enough time for things to show up reasonably, reassembles them into the right order, and then plays them out as necessary. So the groups that work on this, historically this was all done in one working group called AVT, for audio video transport, but the workload became somewhat larger than could be reasonably handled by a single group. So a few years ago, we broke that apart into 4 groups. We have AVT core that works on sort of the stuff that impacts the entire core protocol. For example, there's work going on right now for multipath RTP. We have AVTX, which defines extensions to RTP. So, well, RTP, and there's a companion protocol called RTCP that provides like statistics information in the opposite direction. So where we might send request messages for getting a new layer on a video codec. Payload, which defines the way to bind new codecs, new audio and video codecs, onto the real-time transport. And then XR block, which deals exclusively with RTCP and specifically the types of reports that it sends back. So there's work going on in there right now, for example, to define statistics associated with WebRTC, which we'll talk about in a few minutes. So that's how the media gets from one end to the other. We also have to be able to set up those media streams. And there are actually a few different protocols that do this. The one that has received the most work in the IETF, and this started back in like 1997, is SIP, the Session Initiation Protocol. And what SIP does is it basically, it provides two fundamental services. Let's say I want to talk to Radia. SIP is going to help me get messages to her device, to her phone, for example. This is Rendezvous. Her phone is going to register with the network, say, here's where I am. And that allows me to contact her server and have messages route to her. It also performs negotiation, where our endpoints will talk to each other and determine what kind of session we're going to have. Is it voice, is it video, is it both? Is it going to have, which codec is going to use, those sorts of things, what other capabilities a session can have. So here's a rough network diagram of how this is typically deployed. This is going to look an awful lot like email to those of you familiar with that, where like I have a home server, Radia has a home server, and I send stuff to my server, it sends it to her server, sends it to her client, and that's kind of the way things end up getting set up. The only real difference between the way email typically works and the way that SIP typically works is with email, she can come along at any arbitrary point in the future and pull this from her server. Whereas with SIP, she has to be online and registered with the server, and the server has to know how to get to her device in real time, fast enough that it can make her phone ring reasonably. So there are a lot of working groups that have spun up and spun down over time. Dispatch came out of the RAI side of things, so we've had a lot of working groups that were intended to be small single-purpose type things. We also have a couple of long-standing maintenance groups. M-Music is the great granddaddy of all of this. This is the group that originally developed SIP, and it does multimedia, multi-party multimedia session control, which right now includes mostly things having to do with the session description protocol that we use inside SIP and WebRTC and some other technologies. SIP Core is another long-standing group that works on the core SIP protocol itself. So if we want to change something about the way that, I think it's like, we're working right now on how to make it work better over IPv6, for example. And there might be some work done on DTLS extensions. That sort of stuff would end up in SIP Core. There are also a number of these typically small spin up, do a task, spin down sort of groups that are going on right now. I'm not going to go through them in a lot of detail. We have ECRIT, which is working on like 911 type stuff, ICE, which is working on being able to connect media streams through NATs and firewalls, Insipid, which is working on the ability to get SIP session IDs through intermediaries like session border controllers. Modern, which is working with telephone number assignment issues. RTC Web, which I am going to go into in a little bit in greater detail, but it's basically web browser real-time communications. And STIR, which is a means for getting SIP identities sent from one end of the network to the other in a way that can be authenticated. And this is actually work that the FCC has come to us and asked to do. There's a lot of interest in making certain this works because nowadays the public telephone network is largely based on SIP, and this is key to preventing fraudulent calls. This is not just telemarketing. These are people who are actually delivering invalid caller ID for the purpose of perpetrating fraud. There are also, because these things spin up and spin down, a lot of working groups that are kind of in their twilight. They've basically done their work. They have documents in front of the IASG or in the RFC editor's queue. They're around to handle any cleanup questions that might arise associated with them, but they're basically done. I'm not going to go through these. I just wanted them in the slide deck. If there's something up here that someone wants to know more about, I'm happy to talk to it, but because these are basically going away, we're not really going to spend time on them. Okay? We also have some working groups dealing with codecs, which is the way of taking media and transforming it into typically a compressed format that can be stored or sent across the network without taking up as much space as audio and video would in an uncompressed form. Let's see, these are in alphabetical order, so it's not. Stellar is a relatively recent working group that actually, it's one of the things that I think demonstrates how dispatch works well. We had a group of participants come into the IETF who had previously not done IETF work. They just knew that they had these formats they wanted to have work done on in the IETF and then formal specifications published for them. So they came in to dispatch and within a relatively short period of time got a working group. And what they're working on is standardizing a couple of lossless formats. FFB1 is a lossless video codec, FLAC is a lossless audio codec, and then Matroska, which is a container format for storing these sorts of things like on disks, as well as the binding between that container and the protocols themselves, the codecs themselves. We also have a mostly done working group called Codec. This was the first codec work we did in the IETF, so the name was Codec. It developed a wideband audio codec called Opus, where the goal was to come up with something that was state-of-the-art or better and believed to be royalty-free. And they actually met both of those goals. They met the first goal with flying colors. It's hard. Opus is probably the best audio codec out there right now. And at the moment, it's still believed by most people to be royalty-free. So it met its goal. NetVC is going on right now, where the goal is to do the same sort of thing for video codecs. So we're developing the next generation video codec. We're actually meeting this week. If you're interested in that sort of thing, come by. I'm advertising it because I'm the chair.
It is a lot of math.
It is a lot of math, yes. Sit down with one of the guys who are actually working on the code, and they're more than happy to explain this stuff to you, and you will learn about entirely new branches of mathematics that you probably didn't know before. PERC. So this one is also close to my heart. I'm not sharing it, but I think this is some really cool work that's going on right now. So there's privacy enhanced communications is what the working group is called. And it was chartered to develop protocol extensions to mostly RTP and the other protocols sort of in that area that allow multi-party conferences to be encrypted end to end. And there's also some work that's going to go on in that working group to show exactly how to work that in SIP, WebRTC, and CLUE, which is one of the working groups I didn't really talk about. It's telepresence using SIP protocols. So in a traditional multi-party conference, you have a conference server in the middle, and if it's enlightened enough to be an encrypted conference, which is actually not really state-of-the-art right now, but if people are, locking these things down, then you have encrypted connections between all the participants and the conference server. But the conference server necessarily has access to the media in this set of circumstances, which means that it can eavesdrop on the conversation if it wants to. And that's great if it's in a trusted domain. But more frequently, you're seeing hosted services for these kinds of things, where the conference server is trusted to handle the conference, but not necessarily trusted with the contents of the media. And that's the problem that PERC is being set up to address. So, and this really is a simplified view of how this all works, but the general idea is that we have a key management function that resides in a trusted domain, and it hands out the encryption keys to all the participants. And they use that to encrypt the media that they're sending to each other, but the conference server doesn't have access to those keys. Now, there are some keys that the endpoints use with the conference server to encrypt the parts that the conference server needs to see and potentially change, but which you don't necessarily want to have exposed to the world at large. So why is this important? Like I said, you have a number of interesting architectures where the conference server itself can reside in the middle of the network in potentially an untrusted cloud or that kind of thing. But for enterprise use cases, for example, you might want to have inside your trusted enterprise domain this key management function, which ensures that the cloud service doesn't have access to proprietary corporate information. And then for public internet services, we're making certain that the design of PERC also allows you to take this key management function and co-locate it with one of the endpoints, which means that if there are only 3 people in this conference, those are the only 3 people in the world who can actually decode the media. Those are the only people with the keys. So this would be applicable in like a public internet service that has a mixer in the middle of the network and then just a bunch of web browsers is the use case that I'm most interested in for this kind of thing. Which takes us to WebRTC. So one of the other interesting work groups that we've had going on recently, although this is actually relatively mature nowadays, is WebRTC, which defines the protocols for doing voice and video calls inside browsers, as well as real-time data that you would need to support that, or to do things like real-time online multiplayer gaming. what's interesting about this is because it covers web browsers, there's actually a significant amount of work needs to happen between the web browsers and the content that runs in them, as well as a lot of work needs to happen between the web browsers and the network. So this has been a cooperative effort between the IETF and the W3C, where the W3C is working on the web APIs, and the IETF is working on the stuff that goes across the network, like the session negotiation protocols, STP, the codecs, DTLS, SRTP, NAT traversal, consent to receive media, and SCTP, which is what we use for that real-time data that I was talking about. So I covered all of this. Oh, actually, the last bullet's a really interesting one. So over the years of dealing with SIP, there have been a number of things that have sort of developed as known best practices, at least in the IETF. They're not necessarily well deployed, but the WebRTC effort incorporated these as mandatory. So for example, there's no way to send unencrypted RTP with WebRTC. It's all encrypted using DTLS SRTP. So you basically have, a Diffie-Hellman handshake between the two endpoints, which means that if there's someone in the middle, you're going to be able to detect it. And we also use ICE, which I said we use for NAT traversal, but it also serves the important purpose of determining that the far end wants to receive the media that you're about to send them. Otherwise, you could just start blasting UDP at arbitrary people on the network, and this could easily be used to build a very effective browser-based DDoS system, which we didn't want to happen. In terms of adoption, it's not standardized yet, obviously, but we're getting close, and we have Opera, Firefox, and Chrome already have pre-standard implementations of this, and I'm not sure how well you can read that up there, but Edge on their status page has it listed as in development, and although technically not an Apple mouthpiece, the WebKit page also has it listed as in development with a contact person who has an @apple.com email address. So make of that what you may.
So now we'll talk about some of the things that have been more formally apps. And one of the biggest ones that we have in apps was HTTP. For those that may or may not be familiar with that, what exactly it is it's a request response protocol. So the client makes a request, the server comes back with a response. That's especially true in our HTTP 1.0 and 1.1. This is usually done over port 80, and hopefully that's going away for 443 and TLS everywhere. But it has been used as a transport for many, many new things that are coming along. There's many things that we'll go through that in order to pass the data around, instead of it coming up with their own transport layer protocol, they're just building on top of HTTP. And so really, one of the first questions you're often going to be asked if you're bringing new work is, well, why didn't you use HTTP if you're doing a request response? Most of this has been handled by the HTTPbis working group. So they're the ones that first sat down and formalized HTTP 1.1, updated that to cover all the errata and issues everybody's found. They've also worked on H2. So you can think of HTTP2 as taking the core ideas of HTTP1 and providing essentially multiplexing. So clients can ask for multiple things at one time. If the client asks for something and the server knows that that one thing really you're going to need 4 more things, it could start sending those to you without direct pushing of it, without directly asking for it. It's also helped with header compression, so to reduce the size of each request response. These guys have also worked very closely with the TLS working group. So there's a number of things that, because of how HTTP works, it would be very helpful to have this in TLS. So they've worked with the TLS working group to get that in the core protocol there. And there's been things that TLS has made sure would play nice with HTTP when they've come about. So the two do work very closely together, even if they're not one and the same. Some things that do work with or use or relate to HTTP, we've got CDNI. So this is taking content delivery networks. That's the Akamai's and the other global caches and trying to find a way that these guys could talk together. That's what this working group is for. There's also web push. So you could think of this as kind of enabling the things that you get today with APNS and GCM for pushing data to your phone, making that accessible for web-based applications. Some more things that deal with HTTP or look HTTP-like are core. So this is IoT over something that looks an awful lot like HTTP. They are, for reasons to keep it, fitting within the constraints of very small, low power, low memory devices, they've taken some things to compress even further for their use cases. Although there are some mapping, they are working on defining a mapping to HTTP of their work. There's also SCIM. So you could think of this as users and directories over HTTP. So this is often used between, say, large organizations to populate a cloud service with their users and what the groups those users belong in, and help share that data in a relatively quick and searchable manner. Then there's also TZ-Dist, which is actually closing down this week. This was time zones, so this is passing around your time zone database files over HTTP. So instead of relying on your package manager to hopefully someday update that when some government somewhere decides the time zone is now going to be this is one way to try to pass that information around in a more timely fashion. The other thing that we've also dealt with more in our apps and now art has been data formats. So we heard some things about data formats for real-time media, the codecs. Well, we have a similar thing more broadly here. Oftentimes, we're all pretty familiar with the content, like when you're making that HTTP request and that stuff you get back, or that content you're pushing or posting up. We're very clear, that's things like JSON, that's your content types, that's your content. But there's also other places. What is the context for this? So things like saying or media types, or relating to language. There's also how we identify, how we tag these things. The URLs, the paths, the domain labels. These are all data formats, and these are all things that do get worked on within ART. One of the biggest ones still around is JSON-related ones. So there's the JSON-Bis working group that was taking the original, well, now the standards track 7159 and updating this for fixing some errata and aligning better with ECMA. This is the group that actually defines JavaScript, making sure everything aligns correctly with them. We're covering, you could kind of sort of think of this as what we've done is the over-the-wire stuff, and they were dealing with the abstract understanding of what JSON is. So making sure these two documents are in full alignment now and going on. We also, building on top of that, have GeoJSON. This is representing geographical information, geographical location in JSON. Some people may be familiar with geojson.org. That is the most common definition people have used. This working group is working on the document or set of documents to essentially ratify that as a standard track document in the IETF. Related to these formats, we've got things that are related to language. So there was PERC, the preparation and comparison of internationalized strings. So this was a spiritual successor to string prep once we realized that this problem was even harder than we all imagined. And we were realizing it's even harder than we even imagined the second time around. But the idea is, if I'm getting strings from other places, how can I see if this matches something in my database well? We could just say, well, if the octets all line up, but everybody types things differently, especially if you have things that, case differences and whatnot. There needed to be a set of rules to help computers understand what human beings kind of intuitively know for their region. And PERC was one attempt to try to get there. We also have Logger. This is a working group that's dealing with helping to define what those rule sets look like for people that have validation rules. So the most common one is usually DNS registrars. When you enter a name there, how do you know that it's going to be valid to use? Well, everyone has a different name, has some rules. This is to help define what those rules are and be able to disseminate that. And then we've got SLIM, so the selection of internet media, the selection of language for internet media. So far we've talked about what type of things. It helps also understand what is the language being expressed here. So for instance, in a audio video call, to be able to say, I'm going to be speaking English, but so-and-so might be speaking French, and try to collect that together. Or in the case of email, if I could send something already translated, to be able to say, I have multiple translation, here's what the translations available are. These are some of the things that are being worked on there. just so we're not done with formats yet, there's a few other ones that have come in. So along the lines of our small, fast working groups, we've got just font. This is defining what today is usually application / font dash blah, trying to define an actual top-level font media type. This certainly helps browsers to understand when they're looking at content coming through, is this a font and what is the subdivisions within this font? Is it open type? Is it true type? Is it WFF? What is the type? So the idea here is to define a new top level and to automatically register a number of ones that we already know. We've also got CalX. So this is taking our calendaring and providing extensions to this, whether it's CalDAV, iCal, or the IETF protocols. And finally, we've also got URN-BIS. This is defining what uniform resource names look like. Right now, most of these documents today are all informational. The goal of this working group is to try to take those, apply everything we've learned about dealing with URNs, and make that more standards track. Now, one thing that we've kind of touched on, well, we definitely have touched on, is applications deal a lot with security. Whether it's real-time, whether it's email, whether it's some of our other things, we have a lot of things that touch email, that touch security. And so there's been especially in the last couple of years, a broad movement to do more of this work and see how it directly relates to applications. Being done here, it's mostly since we are focused on how we are getting bits around, it seemed to have made sense to put these groups here. So groups like Utah, or using TLS in applications. They started off by defining the best practices of how TLS should be applied to your application, whether it be HTTP, although a lot of that focus happened in HTTPbis, but also things like XMPP, and moving forward, how this relates to the various pieces in email with submission, with your submission servers, your IMAPs, and how TLS ought to be applied there. We've also have DMARC. What this is, my understanding, although some people here might correct me here, essentially how to know that an email is coming from the domain that it was being delivered from. And there's a number of pieces here that deal with, if that doesn't match up, what should I be doing with this? Is this a hard error? Is this something I just need to flag? Is it okay? And so there's a core protocol that's been defined, but this working group is spinning up to try to deal with some edge cases as well. Some edge cases are actually fairly common. Things, the redirect, what they call the indirect flows. Things like, I send to a mailing list, and this mailing list forwards it out to 1,000 people. Well, that didn't come from me directly. It didn't come from my email server directly. It came through this mailer. How do I know that that was okay? There's also some forwarding services, and this working group is trying to address concerns there on how to make sure this email is coming from a legitimate party, even though it came through this indirect route. Also with it related to security is dbound, or domain boundaries. The primary question they are trying to answer is the administrator for a domain, say foo.example.com, is the administrator for that the same as example.com? For a lot of us, we'd say, well, yes. It turns out it's not anywhere near that simple. Traditionally, we've used something called the domain suffix list to try to figure out whether where those kind of administrative boundaries existed. However, that only helps for things like the TLDs, the top-level domains. It doesn't help us in cases where we may have a hosting provider that is allowing us to have a vanity name under their system, and are they the ones that are administratively responsible for it? Is the owner of the subdomain one responsible? Today, we don't actually know. People take guesses, and they're usually wrong. So the idea with this working group is to try to help define what those boundaries are so that clients can figure this out. The most direct impacts are to web browsers. So things like cookies. Is it okay for me to be providing cookies or to accept cookies from these sites in a related fashion? It might be okay for foo.example.com's cookies to belong there. It might be okay for example.com's if they're in the same administrative zone. If they're not, that could be a very serious privacy leak and possibly even other problems. The other one that's very important is validating certificates. Today, we match on the whole name. If there's a wild card, we try to match on just that label. That sometimes is appropriate, and sometimes that's not appropriate. And having an understanding of where that is would definitely help with validating whether that cert is actually valid or not.
Yeah, just a real quick, I want to go ahead and plug Dbound. If this problem sounds interesting to you, please show up. Subscribe to the mailing list, participate, right. Go. They're meeting this week. They're actually having a little bit of difficulty making progress right now, and some additional eyeballs and brains behind it would certainly be helpful.
We're not.
Oh, we're not. Oh, okay.
But
join the mailing list and help with the conversation. You're one of the chairs, is that right, Pete? Okay.
Yeah, okay. So yeah, if you have questions, I'm sure Pete will be happy to point you in the right direction. Another thing within ART is dealing with security is CAPPORT, or the captive portal interaction. So just about everybody here has traveled, so we've all experienced these captive portals. These are the hotel wireless, the internet cafe wireless. These are networks that are highly restricted. For instance, you can only load a specific web page until you've gone through whatever login or terms of service agreement or whatnot before they grant you access to the rest of the internet or even a larger network within. However, today this seems to work, but it works because it looks so much like a man-in-the-middle attack that, well, it's a man-in-the-middle attack. There's no way for us to really truly tell whether I'm talking to the hotel wireless to help me get access, or if there is somebody sitting in the middle trying to capture all my traffic. Today, those look identical. One of the goals of this working group is to try to figure out how we can have those announcements, how clients can figure out that they're connecting in such a network, and how they can talk to that network. What is the URL I need to go to do login? What are the capabilities of this kind of network? These kinds of things. This is also another group. I don't think they've made a terrible amount of progress. So if this sounds very interesting, please go join the mailing list and talk to them about it. Now we're getting into some things that don't always fit together. The more traditional things for applications, even before HTTP in some ways. So one of these is protocols for email. Right now, there's just really one working group other than DMARC, and that's IMAP append. That's dealing with how making the append command in IMAP work better for uploads from clients. So that right now their clients have to do a lot of guessing whether whether a message upload is going to work or not. This is to help provide them some clues that they can be more efficient with things like that. Right now, there's no other email protocol things going on specifically, but if anything were to come forward, ART would be the best place to be doing that.
So we also have sort of in the traditional protocol bucket something called EPP, which I wasn't familiar with until I started putting this deck together. It's kind of a quiet little protocol that is extremely important. It runs between basically the domain registrars and the domain registries, where, for example, if I go to joker.com to register a domain name, they have to go around and talk to the .com registry to say, I am reserving this for one of my users so no one else can have it. That's what EPP is in charge of. This work was done quite a while ago in apps, and nowadays there's EPP, well, EPP-Ext just became regext. I'm actually not certain what the transition was done for, but they both are working on the same thing as far as I can tell, which is basically extensions to the EPP protocol to accommodate new use cases. So for example, one of the more interesting things that I came across here is that we have some registries that require that you get two names at the same time. There's a NGO and ONG. And if you register something under one, you must have it under the other one. Now, historically, EPP is required you to register these independently. And so one of the things they're working on right now is a way that you can send a monolithic, I need these domains, and they either succeed or fail together, so that you can have the protocol help with the policies that are already in place. Yeah. Okay. And that's it. That's sort of every working group we have, everything we've been working on. If you have any questions, comments, now would be the time.
Criticisms.
Yeah, feedback on the presentation would be good also. Things you would like to, because we do this every 3 or so meetings, and so if there are different things that you wish we'd talked about, go ahead and let us know.
Once, twice. All right.
Man.
I guess you guys can have the rest of your Sunday back.
Yeah, this is a quiet crowd. All right. Thanks for coming, everyone.
Thanks. Thank you.
Are the beards real?
Yes, they are. Thank you for asking.
Hey.
So the Meet Echo guys recorded it, and they're going to put it on YouTube, hopefully by tomorrow. I was recording my own just because.
Prosperity.
Yeah.
So I know I was planning to post it in some of our smart rooms. Yeah.
And I'll.
Rather than pointing to all the websites.
Yeah.